Hello, good evening.
Good evening, sir.
Yeah, hello, good evening. Hmm. Very sorry, we are.
Good evening, sir.
Yeah, good evening. I'm very sorry we are starting a bit late. Um, we had some um emergency meeting with one of our donors, so and that's why we are starting late. As you are aware, you must have seen it in the news that custodian is giving us a three-story building. I hope you will have seen it on. So there
Uh,
was
can,
a
can, can you recap, sir?
yes. I said, uh, I was apologizing for starting the meeting late because we're having meeting with one of our donors, and that is when I say donor here, I mean those that are contributing to the department. You know, giving us items as we need them. Then I said, I hope you saw the news about custodian giving us a three-story building. Did you see it? Mhm. Mhm. You are not aware. So it was
I'm
a
aware, sir.
okay. So it's in the news, and so another group came in about 5:45, when our class was just 15 minutes away, asking us what our needs are and how they can come, uh, you know, to the aid of the department. So as HOD, I can't just push them away because it's an opportunity, especially when, someone is walking up to you and you're trying to help. So we just finished the meeting, and that's why we are starting now. So we'll still cover, the expected area. So before we continue to this class, I would like to take your questions, comments, uh, or suggestions based on what we have done. Do we have comments? Do you have questions? We are quite. Should I just assume that everybody is okay? All right. So um, last week we discussed sampling and sampling techniques and the sampling distribution. Although we started with basic definitions, and like I said then, those definitions or those terms are what we should have known during our undergraduate days, even the sampling and sampling distribution as well. And we were about demonstrating how you can sample from using simple random sampling and then using systematic sampling. And that was why we suggested that the class should be physical so that I can, put you guys through hands-on before we do hypothesis testing. Hypothesis testing is something that I can easily finish in the class since we are actually implementing, using Excel. It's not something that everything is about formula, and so on. So the questions, basic terms, that we discussed: population, sample, parameter, statistic, estimation, estimate, estimator, sampling frame, and then I explained probability sampling, non-probability sampling, and we discussed simple random, stratified, cluster, systematic, convenience sampling, quota, purposive, snowball, or network sampling. And I discussed the errors, that one is liable to when you have to use a part of a population to make judgments rather than studying the entire population. So we looked at sampling error and non-sampling error. And then we also discussed, the major need for sampling. So, so we discussed the sampling distributions of sample means. And we discussed all of this. And I was about showing us how you can estimate, how you can do your sample in Excel. So, and that's where I will start before coming back to the slide for our estimation and then our hypothesis testing. So today might be a little bit long because I needed and our next week will be our last class with regards to. In fact, I may likely finish my part of the two courses, next week. So I would share my Excel now and then demonstrate how we can do sampling with Excel. So just using some basic data. Please don't just, if something is bothering you, please should feel free to. All right, so can you see my my spreadsheet?
Yes, sir.
All right, so I want to create a database. So selected data from database. I have my serial number and I have my names. And then you have other details of that individual, other variables that you have measured. So names, let me just use hypothetical.
Sorry, Prof. Prof, sir.
Yeah, hello, go ahead.
You started from last week. Remember, you taught us how to come into this type of exam, and you've not recap on that area so that we align with you properly before you populate your data. I remember you said we'll go for go to the O, check for the ins,
Yes.
so that for everyone to be on the same page.
Yes. It's the same add-ins that we first semester we did ACS 833, right? Business forecasting.
Yes, sir.
Hello? Did you do business forecasting in first semester?
Yes, sir.
Uh-huh. It's the same add-ins.
It's fruit and it's vegetable.
Okay, let me just put you through because you already know it. We already did it in first semester. I mean the activation of the add-ins. You know, from the file options, you can see it. Add-ins. From your add-ins, you go to manage. From manage, you click on go, and then you select all the options and click OK. So that's how to activate the add-ins. Remember, we used this in first semester. And then what we have activated is under the data at the extreme right. So you have there. Okay. So what we need is sampling. Can you see sampling? Hello, can you see sampling?
Yes, sir. Yes, sir.
All right. So this is the sampling. You click OK. So your Excel can execute random sampling, and it can also execute systematic sampling, which is also known as periodic. So I'll start all over again. So I have a data. It could be the list of entries. So I think you are running a promo, and there have been maybe 20 entries. Let's make it up to 20. Okay, so you have 20 entries, and the serial number represents the unique ID, and then you have the other details about the identity of those that have made entries. Okay. Okay. So, and you want to select a few for your study or uh, for a price or for whatever reason, you just want to select because you don't have the resources to study the whole. So I know that for those of us that are very good with coding, you can easily write an SQL code and you select from your database. Okay, you can just select and that will be it. So, but what if you have other categories of students that are not too tech savvy and they still want to select? So they have their CSV file and they want to select a few from the database and or from that file, and then carry out whatever activity that they want. Now, what you need is actually the unique identifier. So in this case, the serial number here can be used as a unique identifier. The serial number 1, so you have the individual there. XX is the name. So you could also have other columns that that still contain the description of that serial number 1. It could be that you have age, you have the gender, educational level, and some other information. So I want to do the selection. So I want to use my Excel. So in the exam, I can give you a database and ask you to select from it. So I can give you data, maybe with 200 data points, and then ask you to select a sample of size 7, sample of size 10, and then do whatever calculation that that I'm willing to assess. So you go to data and then to data analysis. Then your sampling. Okay. So let's do simple random sampling first. So I will leave it as random. By default, anyway, it stays at random. So it will now ask how many samples are you interested in? So let's assume that one sample of size 5. Okay. Input range, it is the serial number that I will enter. It is the question number is the unique identifier here. Is the one that I will enter. And then I return it. Label in first row because the number of my unique identifier. I just want to select. So I can make my selection to be on the same page. I can make it to be on a new sheet. So let me make it on the same page so that we can compare easily. So my output range to be here. So it will be on D. So we will start pasting from D. Okay? The sample size of 5. So I will click and then.
Sorry, sir.
Yes.
I don't know the formula you wrote inside that input. You wrote something that has a $sign or
No, I didn't write anything. Let me do it again. Let me do it again. So I've selected 5. I will leave this one. Let me do it again. Let me select another 5. Let me just start the whole process again. So what I did was I went to data. When you click on data,
yes, sir.
You had this already been deactivated. You go to data analysis here. You will click and then select sampling, right?
Yes, sir. Mm-hmm.
And then you select OK. I want a random simple random sampling, right?
Okay, that thing is default. Input range. I'm seeing some things inside it.
Don't worry. Let
Okay.
me delete it.
Because in my own, it's blank.
Don't worry.
Yes.
By default, you will not have anything.
Okay.
By default, this is what you will have.
Okay.
This is
That's
what you will
where
have.
my own is like this now.
This is exactly how it will come up. So I want a sample size. I want a sample size of 8. Let's say 8. So inside this number of sample, inside you click inside and then you type 8 because
Yes.
I want to select 8 people, 8 winners. Okay, 8 members. Whatever you are selecting, you have determined the number 8. That's what you want. Now, from where do data to be selected? From where do you want these 8 people to be selected? And that's where I will click this red button. Have you seen my mouse?
Yes, sir.
On this red button, I will click. So it takes me to where my data is. It is the unique identifier that I will select, the unique identifier. Serial number is the unique identifier here. So
Okay.
I will click. Can you see it? That's where the formula comes in. It's not that I typed it. I didn't type.
Oh, okay.
It is by the time you are selecting, the system will be noting the areas where that data is coming from. And here, data is coming from A1 to A21.
21.
Okay. And he wants it to be constant. He doesn't want the data to be shifting. And that's dollar sign, was there. So that when it's doing the selection, it will not change, and the data remains constant, for each of the selection. That's the essence of the dollar that the system by default had added. So I will return back to
Yes, sir.
pane. I'm back here. Now, because
Yeah.
I selected serial number along with it, that's why I clicked on this label. That look, I have selected the label along with the data. So please recognize the first entry as the label.
Label.
So
Okay.
that's why I chose label. Now, for the output where the results will appear, by default, it's saying that it should create additional sheet. I have sheet here, only sheet 1.
Yes,
The
sir.
system will create sheet 2 and then drop the result there. But that's not what I want. I want the result to be on the same page as the data.
Okay.
All right. So I will now select output range. That means I want to determine where the output will be. So
Okay.
I click output range. The system has changed. It has moved away from new workbook ply. It has moved to hello, can you hear me?
Yes, sir.
Yes, sir.
So it has moved away from work and it has moved to range. That means I want to determine where the result is displayed. So I'll click inside it. You can see now the color inside the range. So I can select the point where to be played. It's only the starting point. That's what you need. So I'm on F now. You see?
Okay.
F1. So once you click, it is the system that will put all those dollar sign and so on. It's not you. Immediately you click it, it will just show the position on the spreadsheet. Okay. So that's all.
Oh,
So then I will click OK. The result will start displaying under that F from F1. That's it.
okay.
Now, what do I have? Serial number 5 simply means this person is selected as part of my sample. 8 is selected. So that means TT is part of the sample, PP is part of the sample, serial number 4, SS part of the sample, 11, RR part of the sample, and so on. Now you will notice that there are 2 5s there. I have 5, serial number 5, number 1, serial number 5, the last one. Do you notice it? So
Yes,
what
sir.
it simply means is that the selection under Excel is with replacement. So remember, I was explaining to us last week the difference between selection with replacement and selection without replacement. When you select without replacement, it simply means once a unit is selected and you saw it, that unit will be removed from the population before you select another one. Because it was removed, there was no way it can be selected again because it is no longer available. On the other hand, for sampling with replacement, it means that once a member has been selected, that member is returned back into the population before you select another one. So there's possibility of selecting somebody twice. You know, it is like saying, look, submit entries. The more entries you submit, the higher your chance of being a winner. And then you could also say that you could win multiple times. Just keep submitting. So winning multiple times simply means that the selection is with replacement. Because once you are selected as a winner, you are given another chance of still being selected as a winner. So in that case, you can have a multiple chance, process. So this is how it is selected. This is how simple random sampling is executed in Excel. This is how you can select objectively, without being subjective in your selection. So apart from the raffle draw methods that you can use, table of random numbers that you can use, Excel can also be used in selecting. So I know that I'm going to select serial number 5, which means that the whole of the information of serial number 5 will be accommodated. Serial number 8 is also selected. I can just select all the information under serial number 8 is also captured and well harmonized. The same thing with serial number 4, serial number 11, serial number 7, okay, serial number 16, serial number 16.
Sorry, sir. Please, in what kind of scenario can we apply this sampling with replacement? Like now, if this schedule information data you gave us, they are individual, they have serial numbers, and we want to select the number of people that we want to represent the company
Yes.
in an event. Now, how can you select one person and select another person again? So I want
Yes.
a scenario, a good example of when we can use this with replacements.
Okay. I gave you the example of a promo that you have introduced. Maybe you want to push your product. So you design a promo and you ask your customer to buy your product and submit or text a number that is maybe at the back of their at the back of the lead of whatever product that you are selling. So they push it to you, whether by text messages or something. and you warehouse it. And as part of the publicity, for the promo, you have communicated to your customer that, look, if you put in as many entries as possible, when we are selecting, that you can be selected multiple times as a winner. So that the more entries you submit, the more likelihood that you win the prize. So in this case, you have indicated that someone with a particular unique identifier here maybe can be the phone, the GSM number of that person, because it's unique, it would be unique to that person. And you have assured that that person can be selected more than once. So what it means is that by the time you use any method to select the first winner, that first winner is returned back into the population. You didn't just say, oh, this phone number is no longer in existence, okay, because you didn't return it. But in this case, you allow that individual to be returned, and that individual is now available to be selected again, as being a winner. So in that case, you will have an individual winning multiple times. So that is selection with replacement. So as
Okay,
you have
sir.
selected, that person is a winner, you should return it back, and that person is still available again to be selected as a winner again. So that's the procedure. So you can see all those selection that you have made with replacement, without replacement. Now you know the number of sample. In the first case, I had 5. In the second case, I have 8 as my sample size. So this is how you select with you select using simple random sampling. Now let us see how you can select using the systematic sampling. Remember that systematic sampling, you select at regular interval. You can select at 2 interval, 3 interval, and so on. So after you have identified the starting point. So, but in practice, under your Excel, the starting point is always serial number 1. Okay, so you start with serial number 1, serial number 2, serial number 3, and so on. So now that I have 20 observations, and the Excel will request that I submit the sampling interval. At what interval do I want my selection? It will regard to it as a cycle, as periodic. So the periodic is, how frequently do you want to be doing the selection? Maybe at 2 hours, at 3 hours, at daily, at monthly, weekly, or quarterly. So you specify, and once you click, it will do the selection, starting from the very top. So now let's implement, then I will show you how Excel does it. So again, you go to Analyze, and then Sampling. So it will take you to this landing page. Let me delete so that start afresh. Okay. So this is what we have. Whenever you click on sampling, so this will be the landing page. By default, it will show periodic, and it will show sampling. So for outputs, you have the output ranger, then you have the workbook and the new book. So I want to select periodically, systematically. So I click on period. So at what interval do I want to be selecting? That's the same as the period. So let's assume that I want to select at 4-4 interval. That means the first 4, the fourth one will be my first sample. The next one will be the next 4, 8. You select a sample. From 16, 12, select a sample and so on. So let's put 4. I'm selecting at 4-4 interval, sorry. Under period, 4-4 interval. Then the data, you have to select data again, serial number only, not the other way around. Select your data and then return it. And then output range, let me make it to be from D, okay, so I can see it. And then yeah, that's all. I can click OK. Sorry, I didn't specify that the first number is actually not a number, that it is a label. So I clicked it, so it has generated. Now, remember I said it generates at regular interval, and I said it generates at a period of 4. Now let's look at the serial number. The first selection will be on number 4. The second one will be add 4 to it. It will be number 8. The next one will be add 12 to it. It will be number 12. Then number 16. And finally, number 20. So that's how the systematic sample is selected. I want you to have a look at it. If you have questions, please ask your question. So let me just give you like 30 seconds to have a look at it. And then I'll take your question.
Okay, thank you.
So,
So this second one is systematic selection. But that first one was what?
the first one was simple random
Selection.
sampling. The second one was systematic sampling. So Excel can execute simple random sampling and
Okay.
Systematic sampling. Any other question, please? Okay.
You said it's based on the outputs. Before the output, it was 4-4. That is randomly 4-4, which I expected the output to be on at the end of 4, making at least 5 outputs. But here on D, we have more than 5. How do we resolve that? And on the number 6, there is no output there.
Okay. So remember, 2, 3, 4, 5. We didn't have more than 5. This is a systematic sampling.
Okay, the first 5 up there is not part of it.
In the first instance, we selected using simple random sampling. Here, you specified in advance how many do you want to select, and then we asked you to select 8 out of 20. Okay. In the first one, It was the sample 5. So the system will select 5 at random. So for simple random, the number can be specified. Now let me show you. You can see that under simple random sample, can you see? You can specify the number of sample that you want. Oh, I want 300 sample. I want 5 sample. I want 2 sample. But under the periodic or systematic, specify how your data will be selected. And in this case, we said select at 4-4 interval. 4-4 interval. So which means from the serial number, it will just take the first 4, which is the fourth one here is SS. The next 4, you add 4 to 4, and that gives you 8. That's why you have 8 here. So the same thing, you add another 4 to it, it gives you 12. That's why you have 12 here. And then you have 16. Okay, if you add 4 to 12, you have 16. That's why you have this. And then from 16, if I add 20, if I add 4 to it, it gives me 20. And here are your sample. So let's take another question. Do we have question? Okay. No. So I can go back to my my slide. So I'll stop sharing this and then I will go back to my slide. Our estimation. Remember, we described estimation as a procedure for calculating the value of the unknown population parameter. The estimation can be point and it can be interval. You see, after selecting your sample and then you can do your calculation, there's a possibility that you arrived at a single figure so that you can say the average claim is 24,000 naira on that policy, or the average claim size is now 2, is now 7. So when you use a single value as an estimate for your population parameter, the procedure that led to that single value is called a point estimation. And the formula that you use is the point estimator. But in reality, you might not want to be exact. You can give a range, that's permissible, for you as part of the estimate. So it is possible to have a statement like the average claim size is actually between 20,000 and 85,000. So in this case, you are giving two values to serve as an estimate. So you gave an upper bound and you gave a lower bound. So the upper bound is the highest that you expect, while the lower bound is the lowest that you expect. So expectation does not necessarily mean the reality. I want you to take note of that. Expectation does not necessarily mean the reality. So you can have the expected average income is 28,000 naira. You can also have it as the expected average income is between 20,000 naira and 32,000 naira. So in the first case, you are being definite about the average cost. But in the second case, you are trying to give a range of values that contain average value. So when you have a process that will lead you to two possible values such that one represents the highest, the other one represents the lowest, then what you have is interval estimation. Interval estimation. So you can have, for example, sorry, I'm trying to. Okay. So suppose that you have been asked how long it takes to go from Akoka to VI, and of course your answer can be in two forms. Based on your experience, you can easily say, oh, I think it is 30 minutes. And then you also have the possibility of saying the average time is between 25 minutes and 30 minutes. So the second one try to play safe, as the time would vary significantly. So the 30 is being definitive, while the to 40 is being speculative. And you're just trying to show the two extremes within which you expect your mean to fall. So how do we carry out our estimation? We need some parameters, like the population mean, mu, the sample size, and then you have this simple formula. So for interval estimation, the estimate for the mean is actually S bar plus or minus the margin of error. And you can see the simple flow chart that shows what formula to use when the population variance is known and when it is unknown. Can you see it?
Yes, sir.
And what does it mean? The X bar is the mean and your Z alpha over 2 times sigma over 10 is the margin of error. So the margin of error is obtained by multiplying the critical value, the value from table, which is Z alpha over 2, and the standard error. So when you multiply the two, it gives you the margin of error. So the margin of error is added to the mean to get the upper bound, and it's subtracted from the mean to get the lower bound, so that you can make a statement that the mean is between that lower bound and the upper bound. Now, what is the difference between the sigma known and sigma unknown? So when sigma is known, it simply means that the population variance is known. Then the table that you would use for the critical value is a Z table. But when the sigma, which is the population variance, is unknown, the table that you would use is the T table. The T table. So that is the formula for estimating the value of mu. Now let's look at this simple example. So a departmental store wants to determine the 95% interval, the average amount spent by all customers at for all customers. Okay. So we needed to that estimate, because determine the 95% confidence. It simply means that you should construct a confidence interval. So we have other information. The store took a sample of 100 customers and found that the average amount spent is 82,000 naira. Is there 82,000 naira? And that's the mean. So the standard deviation is assumed. That means you're going to make use of the Z table, and we can construct the confidence interval. So the standard deviation was 20. That means the variance was 400. So these are the parameters. When you plug them together, X bar, look at it here, 82. Z alpha over 2, this is from table, 1.96. Sigma is 20. Root n is 100. You find the square root of it is 10. So if you put that together, you end up getting 78.08 to 85.92. And that is the amount that the customer spent. And what it means is this is it's in thousands of naira. So you simply say that the customer spent between 78,000 naira and 86,000 naira. So it is different from saying that the average amount spent is 82,000 naira. But here, you just want to play safe that you're 95% sure that the customer spends between 78,000 and 85,000. That is the interval estimation example. So you can see that 3.92 is the margin of error. So that margin of error will be subtracted and margin of error will be added. And how do you get the margin of error? Use the multiplication of the critical value and the standard error. The standard error is given as sigma over root n. So please note, the standard error is given by the standard deviation all over root n. So when you multiply that by the critical, when you multiply that by the critical value, that's the value from the table, that gives you the margin of error. So if you add it to the mean, it gives you the upper bound of the expected mean. And if you subtract it, it gives you the lower bound. And then you always make a statement that the mean or whatever you are measuring is between, the lower and the upper. Now, how do you check the table? Because some of you have been asking, this is the table that this man is talking about. How did he come about 1.96? 1.96. Okay. So the Z stands for standard normal. Okay, so when we say Z table, it simply means standard normal table. Now, the standard normal table has figures arranged in rows and columns. The first row, as you can see, are the level of significance, also known as the alpha value. Alpha value. Could be 0, 0, could be 0, 1, it could be 0, 2, up to 0, 9. The first column represents the values of our Z, which ranges from -3 to +3. Now, for you to calculate the critical value is actually that probability value inside the table that corresponds to the level of significance alpha and the Z. So if I want the probability that my Z is less than 0.04, so it means that my Z is already given at 0.04. And the alpha could be 95%, it could be 90%, it could be 99%, or whatever level of significance of your choice. So if I want Z alpha over 2, let's look at the values at the top. Look at the formula. Z alpha over 2. You can see it. Z alpha over 2. And I want to construct 95% confidence. So it means that my level of significance here, if I subtract it from 1, it gives me 0.05. 0.05. Now, but the Z that you want is Z alpha over 2. Z alpha over 2. So 0.05 divided by 2 is 0.025. 0.025. That means I'm looking for the value of Z, okay? That will give me this 0.025. 0.025. That's what you're looking for. So remember, we have a table. That's the table for Z, the standard normal table. And we want to read it. And I said, to read the value from the standard normal table, you need the level of significance, alpha. You need this value of alpha. Okay? And then you also need the value of the Z itself. So, but how do you get it? This alpha over 2, alpha over 2, 0.95 subtract from 1 is 0.05. If I divide it by 2, it gives me 0.025. So I will now go and check the table. Where will I get 0.025? I'm looking for the value of alpha, a value of Z, sorry, that will produce that 0.025. So your job is actually to search through this table and see whether you can locate a value that is exactly 0.025 or a value that is very, very close to it. Now let's go through. So you can see that under 1.96 here, and under here, look at it, the one I'm circling. Can you see it? You will see that the value is 0.025. 0.025. That means that critical value exists. So the corresponding Z that will produce it, it is a Z of 1.9 under 6, under 5. So under 6, sorry, that will produce 0.025. That means the critical value is 1.96. 1.96. Please, you will ignore the sign in this case. It's 1.96. 1.96. That is how we obtained this value of 1.96. 1.96. Okay, which is the same as Z alpha over 2. So while the standard error, which is sigma over root n, the value is given. Just find the standard error, find the sigma, find the n. So if you are given variance, to get the sigma, you will find the standard deviation. And n is 100. So this is how you obtain your confidence interval for estimation. Okay. So now there's also another table, which is the T table. The T table. So remember, from the flow chart, let's have a look at it again. Look at it. From the flow chart, when sigma is known, you make use of x bar plus or minus Z alpha over 2 times the standard error. But when sigma is unknown, you make use of T alpha over 2. T alpha over 2. We add it to x bar and then we multiply by S over root n. And this is what is called standard error. Standard error. But when you multiply standard error with the T table, you get the margin of error. Margin of error. So let's go back to please, if you don't understand what we are doing, call my attention. It won't be nice if we start, getting negative information outside the class when everybody was given opportunity to lay their complaints. So if you have issue, please, you just let us know, and then it's something that we can resolve. So let's look at the case of the sigma squared unknown. When sigma is unknown, how do we check the T table? So I will just want us to have a look at the case, the question, and then we'll go back to the T table just as we did for Excel. So okay, this is how a typical T table looks like. For the T table, you need, yes, Zuchuku, go ahead.
Sir, thank you for your lecture. Good evening, sir.
Evening, well done.
I want to get a clarification on the first case of the known that the mu is known.
Yes.
Just a clarification. What does the mu signify in particular?
Okay.
I know that the S is for standard deviation.
Yes. So, okay, let me go back to where that table is. Okay. So the sigma, sigma means standard deviation. Mu means the mean, average. Okay. So it could be that the database that you have, you have information about the mean. So that if you find the average of all data points, the value is your mean. And you also have information about the standard deviation, because the whole data, the entirety of it is the population. Remember last week we discussed so much about population. So the entirety of it is population, and if you find the average of that population, what you're getting is the population mean. We usually use mu to denote it. The same thing if you have a population and you can calculate the standard deviation, either the variance, when you find the square root, you use standard deviation. So if you have a population that you can calculate or that you have details about the population standard deviation, then that means sigma is known. There's no need for you to estimate it. It is when it is unknown that you will estimate. And then the estimation, of course, will go through the process of selecting a sample, having a look at your readings, and then you will now calculate the mean. Now start showing the child how to do x bar minus mu, and so on. So, or x minus mu, or x minus s bar, and so on. So if you have the information, there won't be any need for you to start calculating the variance from the sample. And that's where the population variance is known. But when it is unknown, you will have to calculate your variance from the sample. So in that case, you are assuming that the population variance is unknown. And when you have used the population, the sample to estimate the population variance, we are no longer using sigma to denote it. We are using S to denote it. When the population variance is known, we use sigma squared to denote it. When you find the square root, it gives you population standard deviation, and then we use sigma to denote it. That is the difference between the two of them. When the whole information is available, you have details about the variance, you detail about the mean, then the sigma is Z that you will use, Z table that you will use. Because sigma is known, you have information mu. Otherwise, if it is mean, if it's a sample that you are using, the mean will be X bar. And then the standard deviation will be S. And they all have implication as to what to use. So that's the procedure. So you're going to make use of the T when the population standard deviation is unknown. And then to make use of the T, just as we have in our Z table, our values are arranged in rows and columns. So you will need information about what we call the degrees of freedom. The degrees of freedom is calculated as the number of sample minus 1. Number of sample minus 1 in the case of one sample test. Number of sample minus 1, that's degrees of freedom. You will now trace it to the level of significance. Level of significance. Let me show you a typical table. Yeah, this is a typical T table. So you will need the degrees of freedom. The first column, can you see it? The first column, 1 to 100, is your degrees of freedom. And I said it's calculated as n minus 1. So if I have n equals to 5, degrees of freedom will be 4. If I have n equals to 80, degrees of freedom will be 79. If I have n equals to 20, degrees of freedom will be 19, and so on. While the values at the very top, they are the level of significance. So I will explain level of significance later. By the time I'm giving you basic definition under hypothesis test. Okay. So this is 0.2. That means our alpha is 0.2 here. Here, alpha is 0.1. Here, alpha is 0.05. Here, alpha is 0.025. Here, alpha is 0.01 and 0.005. So what you need to do is, if you have the degrees of freedom and you also have the alpha, you just trace the degrees of freedom to the alpha that you desire. What you get in there is the T value, and you can use it to make your computations. So let's have an example. So we want to estimate the mean credit card debt of all customers in a country with 95% confidence. 95% confidence simply means that our alpha is 0.05. 0.05. So the sample of 70 households yields the following. 70 households simply means that the degrees of freedom will be 69. Remember, degrees of freedom is number of observation less 1 in the case of one sample test. So our alpha is 0.05. So our n is 70. Then sample standard deviation, not population standard deviation. That means our S is 4007. 4007. And then our X bar is 6312. So how do we make use of the T table to get the value that they have stated there? They got 1.995. So how do they arrive at this figure? So let's check up in the table. So we are supposed to have 70 degrees of freedom. Sorry, number of sample. That means the degrees of freedom will be 70 minus 1, and that should be 69. Okay? That should be 69. That's it. Okay, 69 is there. Then you trace it. Remember, it is T alpha over 2. So if our alpha is 0.05, alpha over 2 will be 0.025. 0.025. So 69, as you can see on the screen, I will trace it to 0.025. Can you see it? And the value is 1.995. 1.995. That is how the T table is obtained. Okay, so at the end of the textbook that I gave you, please, you can make photocopy of the T table, or you just print. There's a T table, there's a Z table, there's F table there. Please make photocopy of those tables. You will need them in the exam. All right, you will need them in the exam. Now, so once you have obtained all of this, then you can go ahead and estimate. And that's how we got it. Remember that it is actually the mean plus or minus margin of error. The mean plus or minus the margin of error. How do you obtain margin of error? You will multiply your critical value, that's the value from table. You will multiply it with the standard error. Standard error is sigma over root n or S over root n. When you multiply the two, it gives you the margin of error. Now, let's look at the case here. Now, you can see that the value from table is 1.995. 1.995. You need to multiply it with the standard error. What is the standard error? Sigma over root n or S over root n. This is S 4007. I want one of you to please volunteer. One of you should please volunteer this value. Now let's get our standard error. Sigma over root n, sigma S over root n, 4007 divided by root 70. Somebody should assist us with that value. 4007 divided by root 70. Uchenna, are you assisting us? Or Paul Ajayi? Paul Ajayi, are you assisting us? Uchenna, I hope we are not all of you are muted though.
So it's 478.9.
478.92.
Oh yeah, multiply it by 1.995.
We have 955.46.
So that's how it's obtained. Can you see it? 955. So that's how it's obtained. So that is the margin of error. Okay. So when you add it, it gives you the upper. When you subtract it, it gives you the lower. So you can say that the average credit card balance is actually between 8,357 and 10,267. So that's how it is obtained. So I'm sure you can do so much more on your own to get more. So now let's go straight to hypothesis testing. And yes, Omotoyibo, go ahead.
Okay, good evening, sir.
Good
So
evening.
sorry, after we got that plus or minus 955.46, where did you get the value underneath?
So you add it to the mean 955. You add it to the mean, it gives you the upper bound. Then you repeat the calculation, subtract it from the mean, it gives you the lower bound. That's why
Okay.
you have it as plus or minus. So I want you to try it now. The mean is already there, it's given. You have computed the margin of error now. So that margin of give you the upper bound of 10,000 above. That should give you the lower bound, which is 8,000 in those two values. That's how to obtain confidence interval. Now let's go through hypothesis testing. Today, I'll just give you the basic terms, okay? The next week, I'll show you how you can implement. And if there's time, we can implement. Remember, I want to finish next week, so we can implement. And you guys are already at home, so you are not in a hurry. So everybody's so now let us discuss hypothesis. When you are testing the claim, checking the truthfulness of a statement. That's what hypothesis testing is all about. When there is a claim and you want to test whether that claim is true or false, your consultant has said that the average returns from a particular security is maybe 20%. 20%. And you want to confirm if that statement is true or not. So you consider that claim of 20% as being an hypothesis, being a guess, okay, about the average returns of that security. So you need information to confirm or reject that claim of 20%. So the process of going through the verification, testing, and then rejecting is hypothesis testing. Okay, so our hypothesis is a guess or a conjecture about the value of the unknown population parameter. So that statement that needed to be investigated for its truthfulness is an hypothesis. So our hypothesis can be null and it can be alternative. Null hypothesis is the hypothesis of primary interest. That hypothesis that you want to accept or you want to reject. It is usually denoted as H naught, while alternative hypothesis is the alternative that gives you, sorry, the hypothesis that gives you the direction to follow when the null hypothesis is rejected. Okay? When that claim of 20% cannot hold based on the information that you have, where else can you, be looking for you to get the real returns of that security? That's what alternative hypothesis does. So it gives you the direction to follow. And then when you're testing the hypothesis, we have that concept of sidedness of a test. So it is the direction that the alternative hypothesis gives. If the alternative hypothesis says, in search of the truth, look for values that are higher, greater than 20%, for instance, greater than 20%. Look for 25, 23, 30. It could also be that in search of the truth, look for values that are less than 20. So it could be 19, it could be 15, and so on. What that you have is look for values that are not it. It is not 20%. Whenever the alternative hypothesis gives you a definite direction, either it says values that are greater or values that are lower, then the hypothesis is a one-sided test. But if it gives you a side, if it gives you two directions, look for values that are not it. Not it means value that could be greater or could be lower. So in this case, the hypothesis is a two-sided test. Now, remember during our definition of terms, we defined a statistic as the formula, the function of sample units. That's what defines a statistic. And then I said X bar is a statistic and so on. But we also have test statistic. Test statistic. A test statistic is just that formula that you use in testing hypothesis. That's all. Or we can say that a test statistic is a function of sample values whose magnitude determines whether your hypothesis will be accepted or rejected. So it is that formula that guides you as to whether to reject your hypothesis or to accept it. That formula is what we call the test statistic. Then there are two types of error that you can commit when testing hypothesis. Remember, hypothesis is about testing the truthfulness of a claim. So a claim might be false, but you erroneously accepted it as true. That's an error. It is also possible that a claim is true, but you end up rejecting it. That's also an error. So there are two types of error that you can commit when testing hypothesis. You either accept a false hypothesis or you reject a true hypothesis. type 1 error is committed when a true hypothesis is rejected. Something is right, but you ended up saying it is wrong based on information before you. While type 2 error is committed when a false hypothesis is accepted. Something is false, but you erroneously or deliberately accepted the other option. You accepted the statement that is false. That's type 2 error. The maximum probability of committing type 1 error, the maximum possibility that a true hypothesis will be rejected, is called the level of significance. The level of significance. So those are the types of error, type of hypothesis that we can have, and the types of error that we can also have. So it is not new. Hypothesis testing concept is not new to us. So this whole idea of population variance known, population variance unknown, also, applies there. So when the population variance is known, the test that we do is a z-test. Otherwise, when the population variance is unknown, the test that we do is a t-test. So which means if it's a z-test, you have to use a z-table. And if it is a t-test, you have to use the t-table. So the same idea that was used under interval estimation is also used here. You have to watch out for whether the population variance is available, it is known, or you will have to estimate it from sample. And that has implication on the way the values are manipulated. So these are typical examples of how hypothesis testing looks like. Can state it in null form. I can state the alternative hypothesis. Now, there are 3 types of tests that we will look at here. 1 sample test, 2 sample tests, and 3 or more sample tests. 1 sample test, 2 sample tests, and 3 or more sample tests. For 1 sample test, that means you have a single population and you are testing, you are investigating, you are trying to confirm the truthfulness of just 1 single value, just 1 single sample that you have selected. That's 1 sample test. So I have just 1 security, maybe GT Bank, for instance. I've been monitoring the performance of GT on the NGX, and I have information about the returns on the stock price. Just for GT alone, just 1 sample. And then I can test information about their average returns or whatever information that I need to guide my decision as to whether to invest in it or not. 1 sample test. We also have 2 sample tests. I have 2 different securities. I have GT and I have First Bank. Then I needed to investigate which of the 2 securities have higher returns. So I can test against each other So I can test the null that they are both equally performing against the alternative that says GT performs better than First Bank, or First Bank performs better than GT, or it's just that they don't just perform equally. Those are the three possibilities. So when you say one is less than lower tail test, one is greater than upper tail test, not equal to the two-tail test. So I can have one-sided, which can be lower tailed or upper tail, and I can have two sided test. So you can see what we mean by one-sided or one-tail test. You can see. So alternative here is saying less than. So it's a lower tail test. Alternative here is greater than. It's an upper tail test. While alternative here is saying not equal to. This is a two-tail test. And of course, you guys can read up this for your example. So I will, we have agreed that next week will be physical, right? For our two classes. I'm ending my class next week, and it is better we have the two classes physical. So next week, please come to the system. We shall show ourselves how to do one sample test, two sample tests, three or more sample tests. And then we close the chapter while for risk analysis, we'll just show us how to do a method of risk analysis. We do the PRA, preliminary risk analysis. We do FMEA, failure mode effect analysis, and then we'll also look at the fault tree analysis. So all of those, they are already in our notes, all the material that I've shared with you. Just quickly go through them together so that we can close and allow Professor Dala to come on stage. So I think we can stop here for now, and we meet next week physically.
Thank you, sir.
Yes. So, do you have questions? All right. In the absence of questions, I shall allow you to
Enjoy our weekend.
Enjoy your day. So, have a great weekend. See you next week. Bye-bye.
Thank you, sir.
Thank you, sir. Good night.